Mr. Lucier's Chemistry! Hello everyone, welcome back to Mr. Lucier's Chemistry class. Now, I think the last thing you covered, you were looking at the history of the periodic table. And they talked about Mendeleev and how he came up with his periodic table. Well, Mendeleev's periodic table, he was able to predict elements based on their masses. So Mendeleev, when he put the periodic table together, he put it together by increasing atomic mass, right? Remember, we read the periodic table from left to right then down. Well, he had it that way. He had it in increasing atomic masses. Okay, that's that bottom number down here. Now, when Mendeleev was coming up with this periodic table, he wasn't the only one. There was actually many other scientists who had came up with their very own periodic tables way before Mendeleev did. But Mendeleev, Dmitri Mendeleev, was the first one to do it and come up with one that made sense and could predict other elements that they didn't know about. Okay? So we're going to take a look today at why these elements behave the way they do. Okay? But we're going to go a little further than the history of the periodic table that you just did. We're going to go back to the electron configuration. Remember when you were doing the electron configuration, the 1s, 2s, 2p stuff, right? We were figuring out the electron configuration so we can ultimately figure out the number of valence electrons. Because remember what I told you, valence electrons are the electrons that are responsible for bonding / reacting. Okay? So it all comes down to bonding and reacting, and that has to do with the valence electrons. Okay? Bonding and reacting. Now, let's take a look at this periodic table here. Okay? Our modern periodic table, the periodic table we use today, is actually put in order by increasing atomic numbers. See the top number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember I told you that top number, that atomic number, tells you the number of protons and electrons. And I said that protons are what characterize the element. There's only one element in the universe that has only one proton, and that's hydrogen. There's only one element in the universe that only has 2 protons, and that's helium. So protons characterize the element, therefore the atomic number is how the periodic table is arranged. Back then, Mendeleev didn't know nothing about any of that stuff. So all he had were masses. But it turns out, as you increase the number of protons, what's in the nucleus of an atom? You find protons and neutrons, right? So if I keep increasing the number of protons, my mass should go up. So Mendeleev, in a sense, was correct in putting the periodic table in order of masses, because what he didn't know is, as the mass goes up, the number of protons go up. So he inadvertently put the periodic table in order the correct way. Even though we use atomic number today, he used masses. Okay? But how does this periodic table deal with valence electrons and how the elements act? Okay? Their characteristics. Well, we're going to take a look at something first. We're going to take a look at the elements in the same group. The group runs up and down right here, right? So we're going to look at the up and down trend. So the first one here is hydrogen. We're going to take a look at hydrogen. And we're going to do hydrogen's electron configuration. It's 1s, and he's the first one, so it's 1. So remember, to find valence electrons, we got to find the highest energy level, in this case it's 1, and count the electrons. Well, there's only 1. So hydrogen has a valence electrons of 1. Okay? I'm going to scoot this up a little bit. Now let's look at the next one in line, lithium, Li. If we do his electron configuration, it's 1s, 2, and then we hit the 2s's, 2s, and he's the first one in the 2s, and that's the electron configuration for lithium. So I'm going to find the highest energy level, in this case it's the 2's, and I'm going to circle the electrons, so we got, look, 1 valence electron. Let's do sodium real quick. What do you guess sodium's valence electrons are? Na, start at the top, 1s, 2, drop down to the next level, 2s, we're going to go through 2 of them. Now we're at 2p, and we go through 1, 2, 3, 4, 5, 6 of them, so it's 2p6. And then we drop down to the 3s, and finally we're at sodium. He's 3s1. So look, we're going to look at the highest energy level. In this case, it's the third energy level. And look, count the electrons, Ve1. So it turns out all the elements who are in the same group running up and down all share the same number of valence electrons. So we know if we move up and down, they'll have the same number of valence electrons. Interesting, right? Now, let's look at the side-to-side trend, okay? Side-to-side trend. Let's scoot this up some more. Okay, so we're going to look at the side-to-side trend. Now, let's pick lithium as our example here. He's the 2s, right? So let's do lithium first, Li. So he starts at the very top with 1s, 2, and then we're at 2s2. Oh wait, he's not a 2s2. He's the first one. So he's 2s1, right? So the second energy level, so we have 1 electron, so we have Ve1. Just like we figured out right here, right? We're going to go to the next element, Be. Okay? So we're going to look at, let me move my paper up some more, Be. Now, if we're going to go look at Be, he is 1s2, 2s2 again, right? But where's he at the 2s's? He's the second one, right? So we're going to come here. We're going to look at 1s2, 2s2. So the highest energy level is 2 again, but this time we have 2 electrons. So Be is Ve, 2 valence electrons. Okay? Now, let's keep going across. We got Li, Be, and now let's go to boron right here, right? So let's draw that one. It's going to be 1s2, 2s2, and he ends up being 2p1, right? So let's draw that out. We're going to do boron now. So boron, B, is 1s2, 2s2, and 2p1. Well, what's the highest energy level here? It's the 2s. And then we count up all the electrons, so it turns out 2 plus 1, we get a Ve3. So what's the trend here? As we move across, we increase the number of valence electrons by 1. Okay? So we increase the number of valence electrons by 1. So if we had to label our periodic table and kind of our groups do it already, we could get a trend for valence electrons. Check this out. I know that, let me get a different color pen real quick. Okay. I know that this first group always gives me 1 valence electrons, right? The second group, since it's next over, will give me 2 valence electrons. Over here, the third group will give me 3 valence electrons, 4 valence electrons, 5 valence electrons, 6 valence electrons, 7 valence electrons, and finally 8 valence electrons. Okay, so that's the trend. As you move across, your valence electrons increase by 1. Okay? Which kind of makes sense, because remember we were talking about electrons in their orbitals. Okay? We were talking about electrons in their orbitals. Who remembers how many electrons go in the first energy level? Well, only 2 electrons go in the first energy level. How many electrons go in the second energy level? We said 8. In the third energy level, 8. In the fourth energy level, 18, right? So we're talking about energy levels here. 2 in the first energy level, 8 in the second energy level, 8 in the third energy level, and 18 in the fourth energy level, right? So, how does this have to do with the characteristics of how elements react? Well, here's how this works. The goal of an element is to either fill up that energy level or empty it out, right? So, in the case of the second energy level, we want to go to 0 or 2, right? In the second energy level, we want to go 0 or 8. This guy wants to go 0 or 8, and this guy wants to go 0 or 18, right? They either want to fill up with electrons or empty out these energy levels with electrons. Well, let's take a look, because elements will always do what's easiest, right? They'll do what's easiest. Just like me and you, you're going to do whatever takes less energy, okay? Now, it takes energy to lose electrons and it takes energy to gain electrons. But these elements are going to do what's the easiest. So, for example, and this is hugely important because it lets you know exactly how these elements are going to react. So pay attention to this part, because this part is going to determine how we know what's going on. Let's look at hydrogen, for example, right? Hydrogen is in the first energy level, right? He's in the first energy level, and he has 1 valence electrons. Well, how many can the first energy level hold? It can hold 2, right? But it can also be at 0. With hydrogen being with 1 valence electron, right? He has 1 valence electron. He has an option. He can either lose or gain electrons. And because he's right in the middle, that's exactly what hydrogen is going to do. Sometimes hydrogen loses that 1 electron, and sometimes he gains 1 electron. Okay? So that lets you know how hydrogen works. We know that if we see hydrogen, he can either gain an electron and react, or he can lose an electron and react. But let's look at lithium, for example, right? Li. Lithium also has 1 valence electron. He happens to be on the second energy level, right? How many can the second energy level hold? 8, right? So with lithium, with having to get 8, is it easier to lose 1 or to try to gain 7? Which one do you think takes less energy? It takes energy to do both. Guys, it's easier for lithium to lose 1 electron than try to gain 7 more electrons. So now I know that lithium will lose 1 electron, that 1 valence electron, he's going to lose it, and he can bond 1 time, right? He can make 1 bond. Let's go to something a little bit more complicated, okay? Let's look at sulfur, for example, okay? Sulfur. We're going to look at sulfur here. Now, looking at the periodic table over here, sulfur has how many valence electrons? He has 6 valence electrons, right? So since I know sulfur, I have put it right here, 6 valence electrons. Let me change pins colors. Sulfur has 6 valence electrons. And what energy level is sulfur at? Let's come back here. Sulfur is on the 3rd energy level, okay? So looking at sulfur, he's on the 3rd energy level. So 3rd energy level can hold how many? 8. He has 6. So the question is, if you have 6 valence electrons, is it easier to lose 6 or to gain 2? Which one do you think sulfur is going to do? What's the easiest? Well, for sulfur, it's easier to try to gain 2 than to lose 6. So now I know that sulfur can make 2 bonds, right? And he's going to make those 2 bonds by gaining 2 electrons to fill up that energy level. Okay? So these might seem kind of hard, guys. Just look at the valence electrons. Look at how many electrons can go into each energy level. And then compare. If I have 5, I'm just throwing this out there. Let's say I'm in energy level 3. If I have 5, it's easier to gain 3 than to lose 5, right? So I know my guy's going to gain 3 electrons and do 3 bonds. So that's how it works. Okay? So let me go through the steps one more time with you just so you have it. Okay? Let's look at our periodic table here. We're going to keep it right here. And you can use this for the test. You might want to keep the video up right here for the test. Now let's give you an example. Let's look at chlorine, Cl. I'm going to look at chlorine. How many valence electrons does chlorine have? He has 7 valence electrons. So I'm going to say Ve 7. What energy level? El, energy level, right? Well, chlorine is on the 3rd energy level, right? He's on the 3rd energy level. So I know that 2, 8, 8, 18, that's how many each energy level can hold, right? This is energy level 1, energy level 2, energy level 3, energy level 4, right? So, I should probably write energy levels, right? So there you go. You have your energy levels. So, I know he's energy level 3, so the max he can hold is 8. Well, let's look. Is it easier to lose 7 electrons or to gain 1 electron? Which one's easier? Well, that one's easy, right? It's easier to gain 1 electron. So now I know chlorine can make 1 bond. And he's going to lose and he's going to gain an electron to make that bond. Okay? So what you do first is you look at the valence electrons, and then you look at the energy level to see what's the max. And then you compare. Is it easier to lose what you have, or to gain to fill up, or to lose to empty out? Does that make sense? And that what you gain or lose will be the number of bonds you can make. Okay, guys, one last thing I forgot to mention. What is the purpose of all this, figuring all this out? Well, we know that if you're going down a group, from the original notes you saw, if you're going down the group, they all have the same number of valence electrons, right? Well, if you have the same number of valence electrons, that means all those elements are going to be doing the same thing. They're going to be bonding by losing 1 electron, because it's easier to lose 1 than to try to gain 8 or more, right? So, you're going to learn later that all these elements, because they have the same number of valence electrons, bond and react similarly. They share properties. Why do they share properties? Because they have the same number of valence electrons, and because they have the same number of valence electrons, they're doing the same thing. Okay? Therefore, their properties and bonds and reactions are all similar. Okay? So, I had to add that bit to it, and once again, thank you and have a great day.